Richard Hong from Taiwan.
Oh.
And this is my presentation. And then
Maybe you should use the microphone for people who follow.
okay, land subsidence is a big issue in the world, and the climate change will affect land subsidence. And these two pictures shows that California and Taiwan, when we encounter the mega drought, and what can we do? And we cannot do anything but pump more and more the groundwater, and that will introduce the land subsidence. So now I will introduce Taiwan is in Asia, very beautiful island, and welcome everyone to visit Taiwan. And it's quite near China and in the south of Japan. And we have a very famous semiconductor factory in Taiwan. And in Taiwan, we encountered land subsidence for a long time because of pumping groundwater. In 2021, we have a very significant subsidence area is around 70 square kilometer. And the maximum subsidence rate is up to 7.8 centimeter per year. It's occurring in this area. And this line is our high-speed rail, and the speed is almost 300 kilometers per hour. So that will result in several concern of the high-speed rail. So our government put a lot of attention on the land subsidence issue. So we built a multi-sensor monitor system, include GNSS, INSA, leveling, and the material compression monitor well, and the extension meter. As of now, first I will introduce the leveling. So we designed 3,000 kilometer leveling network to cover the all land subsidence area. And my company helped our government to conduct 2,000 kilometer spirit leveling. That means a very high accuracy. So we have a very good ground truth to do validation. So from 1992 to 2021, we have a cumulative subsidence more than 190 centimeter, especially in the central in this area. So this high-speed railway. And after the long-term land subsidence, it creates like a bullshit land subsidence. So every year we can produce a land subsidence based on the leveling result. And GNSS, we have more than 400 GNSS stations in Taiwan. So every day we collect more than 300 GNSS stations to calculate. So we develop automatic calculation systems to calculate every day. And we use beneath software and based on the code center, the procedure to do calculation. And we also build the GNS station like this is a very good fundamental. The foundation is around 4.5 meters below the surface, and from the antennas also have a 4.5 meters, so we can receive a very good signal from the GNSS data. Also, after every day, we can calculate the GNS data and interpolate the points into the polygon. And every month, so we can see that during the October to the May, it's the dry season in Taiwan, and the land subsidence will become bigger and bigger. The land subsidence increase very fast, and they become very bigger and bigger. So from June to the October is a rain season, so the land subsidence will become very small. And we also can use a time series analysis to separate the GNSS signal to slope and amplitude. Then we interpolate the data, and we can see that in the central, in this area, we have a very quickly land subsidence velocity. But in this area, we have a very good, very big amplitude. It's quite different. Why? That's because in the dry seasons, we have land subsidence very quickly like this. And in 2021, we have a mega drought. So the subsidence rate is up to more than 10 centimeters. So in the wet season, the subsidence will the service will uplift. So we can see that the subsidence rate is become very small. But in the central area, no matter dry season or wet seasons, you always subsidence. That is a very big issue in Taiwan. That's GNSS can tell us. But because GNSS is quite useful, so we develop low-cost, high-performance GNSS station by our own, like this. So in the past, we prefer to use Leica GR50 and Trimble ROE. That's very good receiver, but it's very expensive. So we developed our own receiver like LS01. So we do some tests. We use the same antenna, and we separate the signal to 3 kinds of receiver. So how about the horizontal difference? These three brands is consistent within 1 millimeter. That means that we can use our receiver to monitor earthquake or landslide because it's the same with the Leica and the Trimble. And in the vertical display, displacement is around 3 to 4 millimeter difference, but we think that's good enough for us to monitor land subsidence. So this is, before I come to Netherlands, my colleague has finished. We spent 2 days to build this one. So in this year, we'll build a new 10 GNS station to monitor the serious land subsidence area. So inside, we use GMT SAR and small base experts method, and with Sentinel satellites every 12 a day, we monitor whole Taiwan. And we also to monitor, this is in Yunnan County, like the GNSS can to monitor land subsidence area like this. And we also do the comparison between soccer and hockey leveling inside, so we do the same thing. So this is our new result. We use 143 images, and we compare inside and the leveling. The difference between each other is within 3 millimeter. And this comparison between INSA and the GNSS like this. And next, we will talk about the extensometer. In Taiwan, we also build an extensometer by ourselves. And in Taiwan, the deepest extensometer is around 410 meters. And this by our company, so this is me. And we have an introduction procedure like this. So normally we draw a borehole and to extensometer, then we draw another borehole to take corn, to take a sample to do soil test like this, picture like this. So when land subsidence occurring, LVDT will transmit the data to our center every 10 minutes. So we can produce the figure like this. So if you have the data, you can know the time series subsidence. But if you only have one extensometer, you cannot know in the shallow area or in the deep area occurs land subsidence. So if you want to know more information about the land subsidence, you need to build like this. We call that group extensometer, and you can separate to several layers. But what does this mean? It means that you need to a lot of budget to build an extensometer because one way to monitor one layer. And so now in Taiwan, we have 8 extensometer and automatic to record data. So we have built a website. When we log in the website, and we can use cell phone, can get information like this. So the last one, we will talk about a multi-layer compression monitor well. This monitor well is in one well, and we install 25 layers in different layers. and we install mechanical ring in different layer, and we just to detect the position of mechanical ring, so we can know which steps occurs compaction, and we can produce the map like this. So in this map can show that the major compaction is in the 0 to underground surface 50 meter, this major compaction. Then, so this is in aquifer 1, then in the aquifer 2. So in Taiwan, we have 55 multi-layer compaction monitor well. So this is a picture. So in this well is around 300 meters. So we will put 78 PVC pipe into the borehole, and in different pipe we will have a mechanical ring like this. And I'm here. Okay, if you have many multi-layer compression well, and you can also do the early warning system, just like GNSS. Every month we can to get the lens subsidence map like this. Okay. So you can also use the MLCW to do the cumulative subsidence map like this. So from this map, we can see that in this area is very dangerous for our high-speed rail. So we can use the multi-layer compression monitor well to separate the data into the aquifer 1, aquifer 2, aquifer 3, aquifer 4. So these are very interesting areas here. So we can see that in the 0 to the surface to the underground 50 meter, there's a very grand sediment, include seal, clay, and fine sand. So if you pump groundwater here, that will produce very fast lens subsidence. And this area is very near our high-speed rail. Our high-speed rail structure is underground 70 meters, so it's very quite dangerous. So we need to do something about this. But how to do that? So we can have some paper about this. So if we keep our underground water up for -8 meters, then the lens subsidence will be recoverable. So if our underground is very dropped very fast, under the -8 meters, and it will become unrecoverable, especially when the groundwater drop very fast and then subsidence will very fast. So that is the meaning of this figure. So now we have a new probe. The new probe can auto-detect the mechanical ring. So how to do that? So we have a probe with every 5 millimeter, we have a sensor. So in this probe, we have 36 sensors inside. So how to do that? Let me show you. So when the lens subsidence will make the mechanical ring move. So when the mechanical move, then we can detect the motion. So we can very easy to calculate the motion distance. So that can automatically to detect the lens subsidence. So now we have also have inside to the test in Union County. This manual, this traditional manual measuring equipment is a yellow point, and the automatic measuring equipment is like a green point. So that's very easy to automatic to detect the lens subsidence. So that's all my presentation. So we have a very actually I am a data producer, so I have a very willing to have a cooperate with all of you. If you have any new idea or method, welcome to Taiwan. Thank you. Thank you. Time for questions. Everybody's getting tired. Very interesting presentation. Did you look at the question otherwise?
Subsiding so much in the south of your van. It's like an alluvial van with a smaller valley system in it. It's so concentrated, the substance. Is it a softer soil there, of what's happening?
Sorry, I can't follow you.
Yeah, so the area of the very rapid land subsidence, it looks like it's geology related, right? So it's not they are just pumping on in the wrong place. So what's going on there? Is that like a thick valley filled in with clay, or?
Oh, you mean the sediment?
Yeah.
The,
Yeah, exactly.
yeah. Okay. So. Let me check. Oh, actually, let me check. Oh, yeah. I prepare the data. Though we have a lot of how to say that the map. In this area, we have many grained sediment like a clay and the silt, especially near the alluvial fan, the end of alluvial fan. But in the middle of alluvial fan, because have a very thin very thin coarse sand, fine sand, and silt. So if you pump groundwater, and because the distance is very short, so it will affect very fast. The compaction will it's very fast. I answer your questions.
Yes, you did. Thank you.
Thank you. Oh. And there's also one.
Okay, a very nice talk. In one of your slides, you show that if groundwater level is below 8 meters, then compaction or subsidence is inelastic.
Yeah.
Does that mean that the pre-consolidation height is about 8 meters? It's very shallow compared to other areas. Yeah, could we go back to that slide?
Yeah, I know you mentioned about it. Like this?
Yeah, so you mentioned that you found that if groundwater level is below 8 meters, you can see the rapid subsidence. That means inelastic.
Yeah.
So that's like the regional pre-consolidation height is only about 8 meters below land surface.
Yeah, according to the book, we also how to call consolidation, pre-consolidation. Only lower than this one, and it will increase very fast. But in Taiwan, we found out that is not. We have a different conclusion with the book. Actually, in the real world, it is not pure material. In the pure material only in the land. So in the real world will be like this. So you can find out the very critical level, just like here. So if the water level lower than this level, and then subsidence will increase very fast, especially when we encounter the mega drop like this, and the speed will very, very fast. Yeah, and in Taiwan, we already encountered twice, especially in this year. Right now, we also encounter mega drop in Taiwan. Yeah.
Really interesting talk. I was curious about your GPS receiver that you designed.
Yeah.
So you were comparing daily vertical deformation, and I was curious if you looked at like 30-day averages. Do you start to see some of that difference between the receivers smooth out, or is there a systematic bias of 4 millimeters? I'm just curious if you could talk a little bit more about that.
Yeah, thank you for your questions. I also very excited for this. So because we have a new project for this, so we just want to know the comparative, or how to say the compatibility for this one. So we compare to ROE and Leica is very good receiver. Actually, before I come to Netherlands, I just buy 8 Leica, but it's very expensive. That's like the money can order to build more and more like this. So we do this test. If you talk about horizontal, it's almost the same. But if you talk about vertical, it's a little bit different. It's a little bit Leica and the Trimble will be good than us. That's because we only use GPS signal, and we need L1, C1 and L2C. I don't know how to explain that. In the future, the United States will launch a new satellite, 32, but now they have around 10 or 12. So in the future, we will the same. Maybe we will better than Trimble and the Leica. After United States launch the new, every satellite, 32 satellite, and this will be good enough. Thank you. So if you calculate daily solution, right now we put a lot of effort on this every day, so we still calculate. So yeah, if we have a new result, I will like to share with you. Yeah, thank you.
Thank you.